Okay, so we're going to start looking at matrices or matrix algebra, and just so you know, this is really just kind of a kind of introduction to matrices, and there are classes beyond, once you get past college, once you get past calculus, that are actually, like you study these very in depth. One of the classes that you would take if you go through multivariable calculus right after that is called linear algebra, and you do a lot of things with matrices, and you start looking at it, from a theoretical point of view. But matrices are a great way to organize algebra, right? It's a great way to organize data, and so we definitely can find use for it in this class, and even as it comes on maybe ACTs or SATs, it's a really good way to kind of organize your data if you have lots and lots of data. So here we have a system of three equations and three variables. And the very first thing says, like, well, let's write it in an augmented matrix. Well, a matrix is just an array of data. And like the data, like outside the context of the problem has no meaning. But inside the context, if you understand like where the data came from, then like the meaning is built into it. And so our meaning is going to be in terms of the columns that these numbers come from. So like, for example, I'm going to look at this first column, and I'm just going to associate the first column with the x variable. And because I already know it's going to represent the x variable, I don't need to write the x. What's important is I just remember the coefficient. So a matrix looks like this, and the coefficient going down there would be 1, 2, 3. And then the next column, the significance of that, or the meaning behind that, it will be just the coefficients of the y's. So that's -1, 3, -2. And one thing you do need to be careful of is that you need to be neat with your organization. And then the z's, that next column, that next column I'm going to associate as the z's. So it's a 1, a -1, and a -9. 1, -1, and a -9. And then the last column is going to be my solution matrix, or the solution column, which is 8, -2, and +9. And it says it's an augmented matrix, and this is what this means. First of all, there's our matrix, right? There's our array of values. It's augmented, and sometimes you get to see this little bar here. It's augmented because it's really like two matrices put together. The first matrix, this one right here, is what we call as the coefficient matrix. And, right, I mean, just like its name implies, it's the collection of numbers that were the coefficients of the equation. And then over here, we're putting it next to this, which we'll call the solution matrix, because it's the solutions to these equations. And so anytime you see augmented, you just combine them both next to each other. Sometimes I just might want the coefficient matrix, so then I would just have the first three columns right there. Okay, but when you put them together, that's what we call an augmented matrix. Now, the next problem, like these are all augmented matrices. And so like if you wanted to, in that first one, you could say, oh, well, what does this represent? Well, it represents like x plus 0y plus 0z is equal to 5. And this one would be like 0x plus y plus 0z is equal to -2. And this one would be like 0x plus 0y plus z is equal to 5. Now, we don't put the x and the y's and the z's because we understand what these are representing. And in fact, if you get rid of all the zeros, go a little bit bigger there, it actually, a little bigger there, okay, it actually, well, not so big, it actually gives you the answer, right? I mean, think about this for a second. Like getting rid of all of the excess, it tells you what your solution is. And so, and to highlight, we've isolated basically these ones down this diagonal. That's huge. That's going to be a big idea that we're going to look at throughout these videos and throughout this beginning of this lesson. But the fact that I have just a 1 and zeros everywhere else tells me what my solution is. That x is 5, y is -2, and z is also 5. So this definitely represents a consistent system, right? It's consistent because I could actually solve, there's one solution. It's consistent, and there's exactly one solution. Okay, so that there it is right there. It'd be like the order order triple, 5, -2, 5. That would be the solution to that equation. Now, for part B, again, looking at this, is it consistent? Well, I'm looking at that last row, and that last row tells me that 2 of the variables, z, equals -4. So if 2z equals -4, then z is -2. And so I know that z is -2, and that would help me like here, because this row right here tells me y plus 3z is equal to 14. And if you know z is -2, I can figure out that y must be 20. And then again, right here, if z is equal to -2, then this row right there tells me that 3x plus z is equal to -11. And again, if z is -2 and I solve, I would get x is equal to -3. So again, this is a consistent system. It is consistent, and it has exactly one unique solution, where x was -3, y was 20, and z was -2. So maybe I'll write that down as well. So it's consistent. There's one solution, and we get -3, 20, -2 is that unique solution. Now, you might say, well, if it's consistent, could you have a different answer than just one solution? And the answer is yes. Yes, you can. And in fact, let's look at part D. We're going to skip C for just a second. But if you look at part D, I've had this row of zeros, right? And it's a true statement. It just doesn't help me solve for anything. But it says 0x plus 0y plus 0z equals 0. That's true. So when you see a row of zeros like that, that's going to indicate that it's most likely consistent, as long as there's nothing else wrong with the matrix. It's going to be consistent, but there's going to be an infinite number of solutions. Because look at what this says right here. Well, this first row says that x equals -9. Okay, no problem. This next row says y plus 5z is equal to 4. And that equation has two variables, and so there's only one equation. Like, knowing that x is -9 doesn't help us. So this isn't. There's a lot of solutions to this. I could let y be 4 and z be 0. That's one of the solutions. I can let y be -1 and z be +1. That's another solution. Like, there's a whole bunch of solutions that would satisfy this. So yes, it is consistent, and there's an infinite number of solutions because we had a row of zeros. And so what would those solutions look like? How would you describe all of them? Well, they have to be an ordered triple, like x, y, z. Well, we know x is going to be -9. Every solution, x must be -9. Okay, so and then here what we can do is we can solve this equation here for either y or for z, and one of them will be in terms of the other, right? One will be dependent on the other. So it might be just easy to say, hey, y is equal to 4 minus 5z, right? If we just subtract that. So I could say that y is equal to 4 minus 5z. So in the y position, I would write 4 minus 5z. And then z can be anything that you want to pick. So z is a real number. So right there, every particular solution, if you look at it as an ordered triple, the x value will always be -9. And whatever you pick for the z value, any number, its y value will be 4 minus 5 times it. And I mean, you could also have solved for solve for z in terms of y, and you would have gotten an equivalent answer too, where y could have been the independent variable and z depended on it. But when you see a row of zeros like this, that's a good indication that it's going to be consistent, but there's going to be an infinite number of solutions, because basically you don't have enough equations to match the variables. So you're always going to have a little bit of ambiguity. Now, we skipped C on purpose, and we skipped C on purpose because here's what's going to look like if you have an inconsistent system. I mean, think about this for a second. That right now that statement says 0x plus 0y plus 0z is equal to 2. And we know that's not true, right? 0 doesn't equal 2. So when you get a false statement like this, right, where you can't, that doesn't make sense, then we say it's an inconsistent system. If this matrix were to represent a system of equations, that system would not have any solutions. Inconsistent. And even though we know the x would have been 0 and the y would have been 0, we don't know what the z is, and so that doesn't work. It can't equal, all of those can't equal 2. Okay. When I look here, this one only 2 variables, so that's nice, right? This says x plus no y's equals 8, and no x's plus y equals 2. So yes, of course it's consistent, and there's exactly one solution because I don't have a row of zeros. Consistent. One solution. And that solution is 8, 2. Oh, sorry, erase. There we go. 8, 2. Okay. Now looking here, I don't have any rows of zeros. I don't have an inconsistency where like I get a whole bunch of zeros equaling a number, but I do realize that there are 4 columns here in the coefficient matrix and only 3 rows. And so if I call this now maybe like WXYZ, right, to give some context here. So go away color, there it is. Okay, WXYZ. This says that W must be 4. Okay, so I know that W equals 4. This next row says X plus Z equals -5. And this last row says Y equals 2. So a solution to this would have 4 components. So it's not an ordered pair, it's not an ordered triple, it's an ordered quadruple. It's going to be in the order of W, X, Y, and then Z. And we already know that W must be 4 and that Y must be 2. So those 2 are going to be fixed. So I know every ordered quadruple, there's going to be a 4, and then there's going to be a 2. So now the question is, how do we represent the X and the Z? Well, because there's a relationship that exists between the 2, one will be an independent variable and one will depend on the other. And it really doesn't matter. So like if you decide to solve for X and say, oh, X is equal to -5 minus Z, that would mean that 4, and then here's what X is, -5 minus Z, and then our Y value is 2, and then Z is sort of like your free variable. Z is your real number. So as soon as you decide what Z is, X depends on it, and you could find it. Or if you wanted to, you could have solved for Z. So Z is equal to -5 minus X. And when you wrote that solution, you'd have 4. And then X could have been anything. Your Y was 2. And now your Z would have been -5 minus X, where X is the real number. So either this is a fine answer or this is a fine answer. But please realize that there's an infinite number of ordered quadruples, right? As soon as you decide X, you've got another solution to the system. So yes, it's consistent, and there are infinite number of solutions to this. And again, this one didn't have a row of zeros, but in theory, it kind of did, right? Because who's to say that we couldn't just do this? 0, 0, 0, 0, 0. So maybe it was it did have a row of zeros, but then, we eliminated it. It's still okay. We can still interpret what that means. Okay. So, a lot of just definition and background, and these videos, this first part of this section, that's going to actually be most of what's happening. We're just learning some new terms. We're learning new ways to like organize our data, and especially since they no longer teach matrices and Ha2 anymore. So we're really all at ground zero, so to speak, of learning how matrices work in math class.